Hi, I'm Lomber Molhatra.
And I'm Lomber.
As you and I both know, visual processing is split into the what and where pathways.
Previous studies have suggested this may also be the case in the auditory processing.
However, before now, there have been no behavioural studies to investigate this.
So today, we invite you into our lab to observe the double dissociation of the what and where processing in the auditory cortex of the cat.
Here is Andy. He's one of 3 cats we've been training for 8 months.
Meow.
The first experiment is a spatial localization task. Here we have a semicircular arena consisting of 13 speakers spread equally around the circumference. Andy has been trained by positive reinforcement so that when the broadband noise is emitted from the speakers, he responds by moving towards the perceived source of the noise. Andy has a success rate of 90% in correctly identifying the location of the sound. Here he is in action in our control experiment. As you can see, in this case, Andy localised the sound correctly and received a high reward treat. Now, using a cooling loop, we are going to deactivate the posterior auditory field in Andy's brain. This process is reversible and does not cause any harm or permanent lasting damage. We will now repeat the experiment to see if this affects how Andy localises the sound. As you can see, although Andy moves generally within 60 degrees of the target, his rate of accuracy drops down to just 15%. For failing to localise the sound, he receives a low reward treat. When we deactivated the anterior auditory field in Andy, the sound localisation performance was unimpaired and did not differ from control levels. When we simultaneously deactivated both anterior and posterior auditory fields, performance was impaired, but no worse than just posterior deactivation alone.
Fabulous, just as we hypothesised.
Our second experiment is a sound pattern discrimination task. We have trained Andy in similar ways to the first experiment. We will play 5 identical Morse code type sequences of broadband noise. The 6th sound will either be a match or a non-match. Andy has been trained to move towards the black circle when the 6th sound is a match, and towards the black square when the 6th sound is different. We trained Andy until he showed a success rate of 88%. Here is Andy doing his stuff. Now, using a cooling loop, we are going to deactivate the anterior auditory field in Andy's brain. We will now repeat the experiment and see how well Andy can discriminate between the patterns. As you can see, Andy incorrectly identified these as a match and moved to the circle. He is given a low reward treat. Andy's performance dropped to 48% following the deactivation of the anterior auditory field. When we deactivated the posterior auditory field in Andy, the pattern discrimination performance was unimpaired and did not differ from control levels. When we simultaneously deactivated both anterior and posterior auditory fields, performance was impaired, but no worse than just anterior deactivation alone.
Thank you very much for visiting our lab today in the University of Western Ontario. I've been Lomber Molhatra.
And I've been Lomber, and this has been Andy.
And I've been the voice.
You've been fabulous. Hi, I'm Lomber Molhatra.
Spatial localization task. Here we have a semicircle.
Hi, I'm Lomber Molhatra.
And I'm Lomber.
As you and I both...
The first experiment is a spatial localization task. Sorry. My head's in the roof.
Hi, I'm Shweta.
We trained Andy until he showed a success rate.
I felt you laughing.
I thought you laughed.
I'm sorry. So today we invite you into our lab.
Lomber Molhatra.
And I've been Stephen Lomber. Sorry. I'm so sorry.
Correctly identifying the location of the sound. Here is an action.
Ellie! I tried!